Hi, welcome to Null Zero Labs. Today on our first video, what we are going to do is we are going to set up our first test lab, and that is going to involve delivering a redundant internet service to this customer here in the brown grey block. So in this red square today, we are going to concentrate on setting up a router with a test point, delivering the two on-site ISP routers, handing off to the customer with a VRRP so that they've got a default route to point at, and we are going to make sure that their customer allocation address is routable across both links during a failure. So we're going to get that bit all configured today, and then hopefully we'll move on and do some more labs where we add in the customer side of the configuration, and they'll add and set up their Palo Alto firewalls here. So we'll start with this process here to get us started for our maiden video, and we'll see where we go. So let's hop straight into the config screen. Right, you'll have to excuse me. This is I've been used to playing computer games for many years, and just having to just play games and shout and scream at a screen, having to put this together and be coherent for a video is a new one for me. But anyway, I digress. We will start with the ISP. So we know at the ISP we want a test point. So let's give this router a name first so that I don't lose track of it. So it's called the ISP pop. Yay. And we want a test address of 1.1.1.1. So we're going to put that on our loopback address. We're going to call it our test point, because obviously we're not connected to the real internet in our lab at the moment. So we have our test point address of IP address of 1.1.1.1. Okay, don't need it because it's always up, but there we go, no shut. So we have our first interface configured. We have given the interface of loopback 0 the IP address of 1.1.1.1. So now if we do ping 1.1.1.1, we get a response because obviously the address is there and it's local to the router. Now down to the two on-site routers that we're going to deliver at the customer, we've got two Ethernet links. These could be fiber, could be anything. We'll get more into detail of that later as to when we do the failover problem, why it could catch you out. So if we look, we have two ISPs applied /30 addresses for the point-to-point, and we have the customer allocation. So let's configure the two downstream facing interfaces. So if we jump onto G0, and we're going to go, this is going to ISP R1, and it's going to have an IP address of, we said there, 203.0.113.1, which will be our side, and it's a /30, so it gets a 252. There we go. This interface we do have to issue the no shut. There we go. Interface is up. The other interface we have going towards the customer is G0/1, and we will say this is going to ISP-R2, and it's going to have an IP address /30 IP address of 203.0.113, and we will say that we are 5, and we will no shut this. Okay, we now know we've got a customer allocation, so we'll route that. Initially we're going to route that and say it's available via both links, but we'll soon see where the problem starts to arise and where we have to start making some clever adjustments to enable us to be staying online. So at the moment we will just do an IP route, and we will route the customer's prefix prefix towards them. It's a 240. And we say that that's available via the 203.0.113.2 gateway. And it's also going to be available via the 6 gateway, which is basically the IP addresses we're going to put here and here. Okay, so that should be it for now on this one. So let's jump on to ISP-R1. Enable mode first, then config. Okay, so now if we, let's do the same. Let's give this a host name. So this is ISP-R1. In G0/0. The description is to the POP. And it has an IP address of 203.0.113.2. And this is 255.255.252. And we're going to no shut this. Okay. Up. Now what we'll do is we'll do a ping to the other side. So it's 203.0.113.1. And there we go. So we can now ping the interface at the other side of this circuit at the POP. Can we ping the test point? No, we can't. And the reason why we can't is because we haven't put any routes on this router yet to say that we want to send the traffic upstream if they can't find anything locally. So what we're going to do is, because this customer is just having a default, later on in videos future up that will be coming up, what we do is we'll do some BGP lab ones where we will do a BGP pairing with a customer, and then we'll accept the customer's prefix and we'll do it that way. But this is just going to be a very basic default customer, and that's it. So we can't reach the test point, so let's do an IP route, and we're going to say anything is going to go upstream to 203.0.113.1. So now if we do the ping, there we go. So we can now hit the test point. We can now continue our journey through the ISP onto other networks. We have our simulated reachability from the gateway so far. So that's all good. So let's jump over to the other one and get ourselves into a similar state there. So same again, we'll give ourselves a host name. We are ISP-R2. And we're going to jump on the interface to the POP. We are going to give it an IP address of 203.0.113.6. And obviously a /30 subnet mask. We're going to no shut it. Again, we'll do our basic test. We will try and ping the gateway, the upstream IP address of the other end of the circuit, which we know should be 5 because we are 6. So the one over there should be 5. There we go. So we've got reachability again from this interface to this interface. So we know our point to point from the POP to the customer's second edge device, edge router is working. So we're all good there. So next step, we're going to route upstream. So IP route, anything else, we're going to send it to 203.0.113.5. And now if we do a similar test again, we see we can ping the test point. So we now know that our 2 point-to-point links are up, communicating with the ISP. They're now working as expected. So that bit's all fine. So let's jump on to the redundancy side of the configuration. So at the customer side, we're going to use VRRP or HSRP, depending on what you like to use, whatever your flavor is. I like VRRP, others prefer HSRP or hot standby. So what that does is, think of an imaginary router sitting here in the middle of these two routers, and it's got an address of this here. It will float between these two devices. So later on, when the customer sets up their default route for everything else like we've done, they will point it at this address. If they pointed it at this address and it was physically on this interface here, if this router went off, that IP address would stop responding. So they wouldn't be able to then go over here. So what the hot standby does, or the VRRP does, is it creates like a virtual IP address, a virtual router that will float between these two nodes. And depending on the status and how we set it up, it will allow the downstream to not have to think about where the traffic's going. We'll handle that here, and that's what we're going to set up now. But you'll see that, well, it's not always that simple. There's some other things that we need to adjust to make this work. So let's have another swig of coffee and get on with it. Right, so let's set up the VRRP first, or should we let's do VRRP. It says VRRP on there, so I'm going to assume they want us to do VRRP. So int G0/1. Okay. So first, the customer's got a /28. So we've got a need to use 3 IP addresses here. So we're going to use the first 3 as the ISP. The customer can then use the rest of those for their own use to direct. And just on another note, there is a VLAN of 999 tagged and trunked across here, and these are in the access points for VLAN 999. That's what the customer has set up so that we can come in. You could always have 2 switches down here and bring an internet VLAN into another switch. You don't necessarily have to have switches in front of the firewalls. I'm just doing this so that it shows that there's a separation, a path, a flow. So if we look at G0/1, we're going to give it not the first IP, because we're going to use that for the special floating one. So what we're going to do on this interface here, we're going to give it the second one and the third one. So the second one for router 1, the third one for router 2. The first one will be our virtual IP address. So IP address here, the customer allocation is 198.51.100.2. Oh, I forgot the word address. And I set the last one. There we go. Right, so it's got the first IP address, the second IP address. Okay. And this is description. This is going to be ISP-R1-LAN. So this will be the customer's LAN side. We might as well no shut it as well. Okay, we can see it's up. Perfect. Now, what we'll do is we will VRP. No, that's the command I'm looking for. We're going to give it a group name of 1. We're going to be good. We'll start at the top. We're going to do some authentication. We're going to authenticate using MD5. Going to be a key string, and it's not going to be encrypted, and we'll just call it password. Obviously, this should be something other than password, but password will do nonetheless for now. So virtual group 1. Now the IP address we want to use here. So the IP address we're going to use is 198.51.100.1. First one. We also want this device to always be the master. If everything comes back up, everything's functional, traffic should always go via this first link. Because let's say this customer's ordered 1 gig for their primary connection, 200 for their secondary connection. they're going to want to be using the most bandwidth 98%, 99% of the time. So we're going to set that we want to always become the master. And now that brings us on to the other one, is that we will set the priority. We want this one to be priority of 100. So that should do us for this side. So now if we do a show VRRP, we can see that the virtual IP address is 198.51.100.1. It has a physical IP address of .2. You can see its priority is 100. It is set to always become the master. And we've got no tracking set up or anything like that yet. So this is just basic VRP. So we've done this side. So now let's jump over onto this side. And we're going to do the same again. So on the second router, G0/1, and get the right one. Description, just for, what do I call it over here? ISP-R2, so we'll do ISP-R2-LAN. And the IP address, again, we said it's going to be 198.51.100.3. That's the physical IP address. Okay. Now let's set up the VRP on this side. So VRP 1. We're going to set authentication. So it was MD5, key string, and it was password. And then we set what the virtual IP address was. The virtual IP address was 198.51.100.1. And we can see it's already linked and it became the master, which is not what we want. But it's got a matching priority, which is probably, it then used another metric to become the master. So what we would do is we will now set the priority to 50. We'll set this one lower. State is master. Master router is 2. Or I've got a feeling we haven't got that trunk set up. So what we've got here is what we call a split brain scenario. Let's double check. Let's just check the rest of our config first. Do show run in G0/1. So we've configured the virtual IP address, we've set the priority, and we've set the password. That should pretty much be all we need for this side. So let's just, yep, we've done the authentication, we've set what the virtual IP address is, we've set the priority. There's nothing else we need to do here. So let's check the customer's equipment. Ah, it's not on. So let's start the customer equipment up. And then what we should see is that this one will become the master because it has a priority of 100. And we've also set that anything lower, if anything, any other device that is lower takes over and becomes the master. Once we've stabilized and we've come back online, we should become the master again, and that's what we want to happen. So let's just wait for those other devices to boot up. But whilst that's happening, there we go, straight away. State change. So router 2 has now changed from being the master to the backup, because there is now a path between the two routers for the VRRP packets to transverse and see each other. So now if we do a show VRRP, we can see that router 2 is now in the state of backup. So it doesn't have control of the virtual IP address. Its priority is 50. We've got authentication between the two devices. The master router is 100.2. So now if we jump over here, should see nothing pretty much changed. It's all the same. It's got control. It's the master. So now if we jump up to the POP and we ping 198.51.100. What did I say it was? 1. There we go. We can reach the VRP address. We can reach the physical address of R1. We can reach the physical address of R2. Now, if I ping that same address again, the virtual one, and I source it from L0, it takes the route down here. So now if we have a look, we can see we've got this scenario going on where, actually, it's probably going this way somehow. So you can see there's an issue. If I was to stop one of these links, the traffic wouldn't get there properly because the route won't change because the routes are set the same. So the link could go down and the traffic will keep trying to go that way even when the VRP is up. So if we go to, we can test it from this side first. It's the easiest way to demonstrate this. If we int g0/0, because I think it's going by that g0/0. Let's just shut that one a minute. Okay, that worked. Okay, let's no shut that. Let's or actually let's do it like this. Let's save that. Let's stop this one to simulate the failover. We'll see R2 has now become the master. So it has a default route. It is now the master. So now I want to ping 1.1.1.1 with the source address of G0/1. Right, there we go. This simulates it. So now you can see the customer's router has gone down and the second one has taken over as it should. So from this side, the default gateway address worked. They would route, they're trying to go up this way. The problem is at the ISP side. So if we have a look at the ISP side now, we can see because we've got the two static routes in there, it's trying to send the traffic via this one. And we can manipulate, we can put a metric in and make it float. Even if we tried to make, so let's do that. So let's make it float. So let's say, okay, that's a problem. So we'll go, okay, instead of where we put where we gave here. So see, instead of where we said, oh, we're going to send that down. So if we put a metric of 200 there, so that it would take over if this failed, but because again, you can't always guarantee that a link or an interface is going to go down, because at the customer side here, this router might be behind another device. So this interface would stay up and the route wouldn't change, because it would still see that the interface is still available via that route. It can still see the IP address up, so it'll still try to send it. So the traffic will never return. So we could do it this way. So on the customer device, on the POP side, what we can do is on the what we will want to do is, there we go, on this one here. So what we're going to do first is we are going to set up an SLA to track the IP address of this primary device, so that if the primary link or the primary device fails, we want to remove this route out, so that we can return traffic down the backup link. So how are we going to do that? So what we're going to do is we're going to go and do an IP SLA. Just give it a 1. So IP SLA 1. We're going to do ICMP, and we're going to echo to that address. So 203.0.113.2, which is the address here. Because again, if you do some of these things by interface or by protocol, the interface may stay up on the device, which means that the tracking will never see the interface go down, which means the failover will never happen. So we'll say now we're going to source the ping between that destination IP with the IP address of the other side. We'll set a frequency of 5 just for, and then we'll set a schedule so we'll start pinging it. So schedule 1, the lifetime will be forever, and we will start now. So now we'll do a show IP SLA summary. Right, so now this router is now sending a test ping from this address to this address, and it's failing. So now, because we know it's failing, we can now use that. And what we're going to now put in is, because we've now put that SLA in place, we're going to now use a track, and we're going to use that track to manipulate the route. So let's track 1 IP SLA 1, and we're going to check for reachability. Now if we do the same, we'll do a show track 1, and see reachability is down. Okay, so now what we'll do is, under the routes where we had this route here, which is the primary route, we're going to take this one out. We're going to paste it back in, and then what we're going to do is we're going to track it. We're going to track it with that track 1. Okay. And what we're also going to do is we're going to set this other one to be a float. So we're just going to give it a little bit of a higher metric, so that it's not in place unless the other route is not there. So just set 200. So now if we do a show IP route, what we should see is that we only see one route, but the path now for that subnet is via .6, which is this gateway. So we've now manipulated that if somebody goes and switches this device off here, or even if this link doesn't go down, if this IP address never becomes reachable from this device, we can change the route. So now when we go back over to route 2 and we send a ping, we get the response. So now let's start R1 back up again, and we'll come across the next problem we're going to find. So R1 will come back up, it will become the master, and what will happen is customers on this side will still be sending their IP, their default route to 100.1. They will then hit this router instead. They will then go up here. The route will change because we will have reachability. And we'll see that everything is right in the world. But there can be another problem that will happen. And we'll cover that now. This is one that sometimes you don't think about. You think, oh, there we go, it's working. So if that router goes off, this router takes over, customer traffic now flows up to the POP and onwards. Everything's right with the world. Everything's working. That's what you'd like to think. Right, so now we can see on the POP side, we can see we've got a report that the SLA has now gone from down to up. So now if we show IP SLA summary, we can see this interface is responding. If we show the track, we can see it's reachable. So now if we show the IP route table, we should see, there we go, that the customer subnet is now available via the primary link. So again, router 2 can reach it because router 2 will go up, but the traffic will come back down this way, asymmetrically, which is fine, which is what we want. So now, if we jump on to R1 again, let me just move it here so we don't get confused. So show VRRP. So it is the master. It is working. Cool. Everything is now pretty functional, but there could be another problem. So let's say I do this. On R1, let's just shut this interface off. So what we're going to see happen is the ISP will do what it's meant to do. It will go, hey, I can't reach that interface now. I'm going to change the route. So it will change the route to go this way. But if you see here, this route is still up. At the moment, VRRP is configured to just say, hey, if this box dies, fall over to this one. So as far as this is concerned, if we look at ISP1 now, and we do a show VRRP, we can see it's still the master. So that means everyone here is still sending their traffic to R1, but R1 can't send it anywhere else because the interface is down. And so it's not going to get anywhere. So it won't reach. So if we try and ping from here, we're okay because we're fine there. We try and ping from R1 or ping from anything else behind in the network. Source would be, yeah. Oh, no, I didn't shut it down. Wally in G0/0. Let's shut it. Cool. Right. Now that interface is dead. That could be someone's unplugged it. There's a fault on the cable locally. But Now we see this side has changed at the ISP. It's done what it's meant to do. Everything's gone right in the world ISP side. We're saying, yep, send us your traffic this way. But as far as we're concerned at the customer side, nothing happened. All the traffic is still going here. Because what we also need to do is we need to track the status of this interface. And there's two ways of doing it. So if we bring that back up, and we bring that interface back up, we can do it this way. So if we jump onto the VRRP interface, which was int g0/1, and we do VRP1, and we say track. We say track 1, and what we'll do is we'll say we'll decrement. The other one is already at 50. So and we're at 100. So if we decrement by 60, that will put us at 40, which will put us below the secondary router, and the secondary router will become the master. So that's fine. And then say we go track 1, and then we're going to track interface, and we're going to track the outside interface 0/0, and we're going to track the line protocol. You might think, okay. So we've done that. Let's simulate again. If I jump onto G0/0 and I shut G0/0, we can see the line protocol went down. The state changed. This became the VRRP master over at R2. R2 is now the master. Everything back here is now saying, yep, go to this router. The ISP went, yep, I can't reach this. Traffic is now coming this way. Traffic is now coming this way. And it's like, yep, okay, all good. Fine. But, like I said, there might be let's do it this way. So if we jump back on R1 and we bring the interface back up. So the interface is up. If I was to go to the remote side, so now we can see that R1 is now the master again. Everything's right with the world. This one has become the backup. The ISP reachability is up. It's happy. It's changed its route to go that way. But if I shut the interface from this side, we can see this interface has gone down at the far end, away from the customer. We look at this side. This side is still the master on R1. R2 is still the backup. It didn't fall over. Why didn't it fall over? It didn't fall over because we're monitoring the interface protocol. So if we look, the interface didn't change this side. The line protocol is still up. See? The line protocol is still up. And that's a problem because you don't always have a connection that comes from the ISP to the equipment on site directly. We may have a OLO supplied NTE device in front of this router, and then the router is then connected to that NTE in copper, and then there's a fiber connection from the NTE which is running back here to the POP. There could be another NTE line card somewhere which is then connected into the upstream router. So you'll never see the line protocol go down, and because of that, the failover won't happen. So again, we're going to have to do a very similar scenario to what we did this side and not track the line protocol. So we'll get rid of that. And we're going to do a similar thing again. We're going to do an IP SLA. And again, we are going to echo the 203.0.113.1 with a source IP of 203.0.113.2. Frequency will be every 5. Because again, what's happening is that even if the line protocol stays up, the underlying line protocol, the IP layer will go down. There'll be no reachability on the IP layer. So if we now change to, instead of monitoring at that level, we set up a schedule again, one lifetime forever, start time now, and then we track one, and we're going to track IP SLA one reachability. Now, because I haven't brought that interface up and the command to track one was already set, we can see that the failover has now happened. So we can see router 2 is now the master. Everything behind going to this IP address gets routed to router 2. It goes up the point-to-point link to the ISP. The ISP's gateway knows that this leg is down, so it's happy to send and receive traffic via this interface. So everything is right with the world. That is now functional. I can now ping higher upstream. If I bring the interface back up, so the interface is now coming back up on the ISP side, we should see this router become the primary again, because its SLA tracker will see that there is reachability. It will then inform the VRRP protocol to become the master again, which it does. So we can now see VRRP is functional as the master on router R1. So it now has control of the virtual IP. Everything behind is now going to this gateway, going upstream to this leg. The ISP knows that that leg is up, and it is now sending and receiving for that subnet via the primary circuit. So we can now see that we now have full reachability, and we're not from the customer's on-site managed equipment. We have now achieved redundancy to the upstream. So we can now say, yep, if there is a failure with this link and the line protocol goes down, we will now change over to here. We can now say, hey, if this goes down, it will now go over and route correctly. So we've covered 3 different possible issues that could pop up to stop that. Even if we changed over, the traffic wouldn't be routed properly. So now we've now achieved our goal of delivering the 2 on-site routers with redundancy, and the customer allocation is now reachable over both the legs. So that hopefully gives you an idea that there's more at play to just setting up VRRP to do a failover. There's other things you have to think about, like the scenario of an interface going down. So sometimes you have to add the additional SLAs and trackers to track things that you want to cause a failover. Again, you can't always rely on the line protocol or the interface to go down. It can sometimes be that the interface will stay up, but there'll be no IP reachability. So you have to then say, hey, I can't track the line protocol here. I need to track the IP reachability instead. And because we've done that, now if someone was to shut this interface down, VRRP will change over VRRP will change over, the interface goes down at the remote side. The routes will change at the ISP side to allow the traffic to flow correctly. So we've covered all of our bases. So what we'll do next is we'll save this lab. I'll save them. I've put the configs for these on the GitHub site, and I will leave a link to below, so you'll be able to see the configuration of all three routers. And then in the next video we will get the additional switches in place on the customer side here, and we will then add a couple of test nodes, and we will check that we can then set up high availability on the Palo Alto, and then that the inside of the customer up to the test address there, and then we've achieved our goal of internet connectivity being delivered to the customer. So I hope you stick around for the next video. Hopefully this will get better as time goes on. Obviously, like I said, this is my first video, so I hope you enjoyed it. I hope if there's anything that could be improved, or if anything that you want to know more about, please leave a comment below. Like and subscribe, and thank you very much for watching.